Professor Adams. Welcome. It's so glad to have you today. Today we're interviewing you for the Finish in 4 office to give some guidance and tips about finding career plans and interests for new students.
Okay.
So do you want to give us a brief introduction of yourself?
Okay. Yes, I'm Paul Adams. I'm a professor in the neurobiology department at Stony Brook. And in fact, I've been at Stony Brook now since 1982. So that's a long time. And well, I'm still enjoying teaching neuroscience at Stony Brook and also continuing a small research program. And I'm very happy to share any wisdom that I can or knowledge. However, do bear in mind that I was an undergraduate a very long time ago. Okay? So I was an undergraduate from, I think, 1964 to 1968. Okay. And then that was at the University of Cambridge in England. You can probably tell from my accent. And then from 68 to 74, I was a graduate student at the University of London.
Oh, that's really like a long time ago. It's really cool to hear.
Yes, it is amazing.
So here comes my first questions. When you were in college, what helped you decide on a major or career path?
Well, to tell you the truth, it was partly accidental. As a teenager, I became quite interested in what's now called molecular biology, DNA and biochemistry, and molecular biology specifically. And that was because when I was a teenager, Crick and Watson, the discoverers of DNA, what they call the secret of life, they had just got the Nobel Prize, okay? Wow. So it was very exciting, and you heard about it in all the media, and then the only media was the TV. But there were TV shows about DNA, and I found this fascinating, and I was, what, 14, okay, 15. So, and then I went to university planning to become a molecular biologist because I thought this was really cool, okay? But basically, I was not a terribly diligent student. I guess I was an okay student, but not diligent. You know, when you go away to college, it's a whole new life and you want to do a lot of other things other than studying, okay? So basically what happened was that I took an exam at the end of my second year, and I didn't do well in it. Okay, up till then, I'd always done very well in all my exams, but this exam I more or less did very badly at. And that meant I could not continue in the molecular biology program. They were very selective. Okay? So I had to choose an alternative. And more or less by chance, I chose a subject called physiology and pharmacology. Physiology and pharmacology, okay? And in particular, that year, it was my last year, I had to specialize in one aspect of physiology and one aspect in pharmacology. And the one I had to go into was neurophysiology and neuropharmacology. And I found it fascinating. And in fact, pretty soon, after a few months, I found it even more interesting than molecular biology because I realized that was the future of biology, you know? The big discoveries had been already made in molecular biology by Crick and Watson, but there were still lots of discoveries in that field. So that's how I ended up as a neuroscientist. It was partly an accident. Wow. But I'll tell you one little story as well. Much earlier, when I was a boy, 10 years old, I did my first electrophysiology experiment. electrophysiology is the study of electrical signals in the brain, basically. And that's very important in neuroscience, right?
Yes.
The signals are all, when I speak, when you listen, when
Yeah.
you, and everything is just the electrical signals, okay?
Yeah.
And I remember vividly, as a boy, 10 years old, I caught some tadpoles, baby frogs,
Mm-hmm.
put them in a little metal dish.
Mm-hmm.
Why I did this, but I did it. And I took a battery and two wires, and I connected one wire to the metal dish,
Mm-hmm.
and then I put the other wire into the water, and the frogs went like that. They jumped.
Oh.
I was fascinated by that. I found that absolutely fascinating, that an electrical pulse coming from the battery caused the tadpoles to jump. Okay.
Wow.
And that's what I ended up doing for the rest of my life. Essentially putting tadpoles in electrodes and what happens. So anyway. So
that's actually so cool for you to do that experiment as 10 years old.
Back then, it was possible for kids to do experiments in nature too. You know, you had more access to nature. You know, so you had to be able to catch the tadpoles, okay? And there were not as many rules. Probably now, you wouldn't be allowed to do that experiment. It was totally harmless. The frogs, the tadpoles were not killed. They were, you know, they were fine. But then, so it was lucky that I was able to do that. Okay, what about the next question then?
Yeah, so here comes our next question. Maybe it's like a long time ago, but like it's going to ask, was there ever a time that you questioned yourself for why you were in college? What did you do to resolve those kind of feelings?
Well, I was also quite interested in other things, you know, literature, and so I wasn't really always sure that I would be a scientist. And then I had this problem that I failed this exam, okay? And I couldn't proceed, which turned out to be lucky. But at the time, it was very depressing. You know, my whole goal in life was to study molecular biology. And I couldn't do it. I was blocked, you see, and I was very depressed. I was depressed. So that was certainly frustrating. But then a new thing comes up, an opportunity to study something a bit different. And in the end, I was lucky. It turned out to be perfect for me, given my background, my interests, you know. And so, yeah, I think you have to be a little bit flexible and not be committed 100% to one particular thing, because it may not work out for various reasons. On the other hand, you do have to respect your own personality and interests and curiosity, and follow, you know, do what you're most interested in. But you have to be flexible. So a combination of these two. It's exactly the same when you study neuroscience. And in particular, I'm very interested in how does the brain learn, okay? And when you think about it, that is actually a tricky problem, because you need to store information in the brain in a stable form, so they don't change. You need to keep the memories, basically. But on the other hand, you have to make new memories, right? So this is called the stability plasticity dilemma. The dilemma is got to be stable, stability, but you also have to be adaptable, plasticity, you see. And this is a very interesting struggle between those two poles, yin and yang, stability and plasticity. And anyway, all right, I think we better move on to the next question.
Yeah, this is getting a little difficult to understand, but that's really good to talk about. And My next questions would be, were there specific experience you remember having great meaning to you? So like some impactful experience such as job, internship, or even like mentoring experience. And what type of experience would you recommend to the students?
Well, one thing that jumps out in my mind was a bit later when I was a graduate student, and I was making progress and I was slowly learning. And then it was almost a miracle when I look back. And a rather eminent neuroscientist who was a friend with the chairman of my department came to visit. And I think he came every year at Christmas. And he would either do a lecture or he was working at Harvard, and he was a leader at that time. And in fact, he's written one of the best textbooks in neuroscience, which is used by everyone.
Wow.
And there were two graduate students, and he more or less said, you're using old-fashioned techniques. I'm going to show you how to use what are called microelectrodes. They're tiny electrodes that are so small you can't even see them in a microscope, and you can put them into nerve cells. And he managed in just a few days to get the equipment that was needed and to show us how to do this. Because up till that time, what I had been doing was indirect. It wasn't a direct measurement, okay? But now I could make a direct measurement and I could see it with my own eyes. And I remember it's the first time I popped one of these microelectrodes inside a nerve cell. You see a sudden change in the electrical voltage, and you know that you've gone through the membrane. And you can't see the membrane. So the only way you know that you have gotten inside the cell is by looking at the voltage. And it was and I'd been reading about this, I'd been indirectly measuring it, but never directly. So that was the ability to really see with your own eyes what you had worked on for several years. And that revolutionized my whole approach, because I switched immediately to that new approach and started. So that was quite influential. I've always had a lot of respect for him. And so that was one incident. It only lasted, I think, maybe a week altogether, but it was influential. And it made me turn in a new direction. And then there have been some scientific ideas associated with individual people that are very influential. But there we get a little bit, more technical. But yeah, it's true that occasionally you have some sort of direct contact with a leader in the field, a genius. That can be quite influential, because some people are just very good at what they do. And you realize, wow, this is something extraordinary, and you can learn from this. And then you just have to, be open to the new ideas.
So would you say like that would be part of like networking or like exploring and keeping up with the field?
No, it's related to that, because in both cases, it was an example of networking. But the key is not just that you're linking up with any old person at all, random people, good people, but random. Those were world-class minds, you see. And 5 minutes with a first-class mind is better than a year with a second-class mind. That's an important lesson, I think. If you get a chance to spend 5 minutes with a Nobel Prize winner, take it, you see, because it could, you'll realize that, that's another level which you can perhaps get closer to.
Interesting. Oh, this is actually unique that I have heard of. So I'm going to moving forward to the next questions. How did you discover your interests and career goals?
Well, we've more or less already covered that. I was interested in science.
Yeah.
I was interested in biology and what I call the frontiers of biology, you know, fundamental biology. I never really wanted to I admit I never wanted to help people or become a doctor or anything like that. I wanted to understand difficult problems. And one of them, of course, was what is the nature of life, you know? But then Crick and Watson essentially solved that problem. So, you know, the rest was detail, very interesting detail, very important, but it was really detail. So the next big problem was not what is life, but what is mind. And that was, and to some extent still is, an unsolved problem. So that was quite exciting. And I've always wanted to be involved in that. And, you know, maybe I don't know why I was ambitious like that, but I thought better, again, the same theme as before, better to try something important and to fail than to try something not important and perhaps to succeed. But at the end of it, well, you've succeeded in something minor. Well, you know, it's much better to try to climb Everest and fail than to walk up a hill and succeed.
Interesting. But we always need.
No, I'm not saying that's for everybody.
Oh, okay.
That was the way I felt, and in a way, you're setting yourself up for failure there. You see, so that is a problem. It still haunts me. It still haunts me that I have not completely succeeded in understanding some of the things I would like to understand. Okay. So that's why I keep going, even though I'm now 73. I would still like to understand how the brain works. And,
it's really actually resistant and respectful.
Yeah. Okay, now any more questions?
So yeah, the fifth questions would be, what advice would you give to an undergraduate student who is having a challenging time deciding what path to follow? For example, like if they have like different interests, like, or they maybe like never have done anything that is like impactful enough for them to want to follow through. So what kind of advice would you have?
Well, first of all, I think having several different interests is actually a good thing, always a good thing. You know, you never know which of those will become your career, and perhaps other interests will not become full-time activities, but they will give you some enjoyment and interest, and you at later times you may be able to take those interests up again. I remember when I was a teenager, I also used to go out and look at the stars. Okay, astronomy I was interested in and excited by it, and then I put that aside because I was, you know, trying to develop my career in neuroscience and all that. And just very recently, I turned again to astronomy and started to look again at the stars, but this time with a good telescope. And I'm a beginner, and I will never contribute scientifically, but it's good to have several interests, I think, other than your main interest, and also to be open to the possibility that later you may switch. You may reach a stumbling block in your career, and then if you have other interests that you have maintained at a low level, then you can take those interests up and pursue them, you see. And who knows, you know, you could take up poetry after being a soccer player.
Yeah, that's also like, so yeah, I just want to conclude that that's also like what you mentioned as being flexible, kind of.
Yes, of course, yeah, flexibility. But the trouble is, of course, you risk being a butterfly, going from flower to flower and never really contributing. But some butterflies have done even that. I was reading it recently about a historian, a famous British historian, who still is well known. Lord Acton. There was a man, he was called Lord Acton, and then he was the guy that said, power corrupts, and absolute power corrupts absolutely. That's a phrase, still true, okay? But I learned, although he's famous, he never actually wrote anything.
Interesting.
Yes, he was influential because he would give lectures, and people would enjoy that. And he had a huge network of friends, and they all trusted his judgment. But in the end, he never actually wrote any historical, book. So the question is, did he make an important contribution or not? It's not obvious, because he's still not well known and talked about, and he wrote some interesting sentences, but he never wrote a book. So anyway, I don't know. I don't know about that. I don't think you have to aim to become successful. That's the wrong approach. You have to pursue your interests. And again, another famous scientist, Cavendish. Cavendish was the first man to actually test directly, experimentally, Newton's theory of gravitation. Newton said that if you've got two masses, this mass and this mass, the sun and the earth, they pull together, okay? And there's force between them. But he didn't test it experimentally. What Cavendish did was to make a very heavy weight, another very heavy weight, and actually measure the force between them due to gravity. It was a very weak force, because compared to the sun and the earth, these weights are quite low. But he actually measured it. So he made this incredible discovery, and then he wrote it down, and he hid it in a drawer of his desk. He never published it. It was a piece of paper and when he was dead, they discovered this paper. And,
wow.
So he was quite happy. He wanted to know the truth, whether this was true. But once he found it out, he didn't need to share it, Nowadays, of course, you would rush out to publish that. But, he was just satisfied to know. And I can tell you a lot of other stories like that, but we don't have time.
So we have to move on, but it's really nice to hear this interesting story of like people doing, like scientists doing things just for like self-satisfactory, and some students may also learn a lot from these stories. So
yes, I don't mean that you should, do something at a superficial level, and then abandon it and do something else, and then abandon it and do something else. You do have to work hard at whatever you're interested in, even if you're not necessarily going to be successful. But the harder you work, the more you will learn. That's another point. That's the best way to learn, isn't it? By working hard and encountering problems and trying to understand. And this is what I particularly enjoy about teaching. Scientists in universities also don't just do research, they teach. So my approach with teaching is, if there's something I really want to understand that I don't already understand, I will teach it. Because that forces me to think about it more carefully and explain it. And hopefully I will end up learning more. So I always think of the most important thing about teaching is that you learn. The teacher should learn more than the students.
I actually hear this before too, like when you try to like teach something to your classmates, that help you to consolidate your own knowledge.
You've heard that before from other professors, perhaps, and it certainly is. There's some truth in this, but don't go too far. Don't choose something completely different. Don't say, "Oh well, I'd love to know about understand relativity theory, okay? Now, I know that I don't know enough physics to teach that. So you have to teach at what you know almost, but you know that you can go a little bit further, and then you will explore. And hopefully the students won't realize while you're teaching that you actually yourself struggling to understand the concept. You still have to be ahead. You still have to be ahead of the students. Okay, you can't go into the classrooms and admit that you don't know anything, and that would not be good for anybody.
Okay, so here comes our last questions. Okay. So that would be something about neuroscience. Like I know there, like in biology or in neuroscience, there's a lot of topics. Like people study like different brain disease, or like some of them have the concentration in like neural development. Some of them concentration in behavior, or something like that. So what would you recommend students to do to maybe narrow down or explore these different aspects and find out what they want to do, kind of like find out their interests?
Well, it is a huge field, and there's a lot of different things to pursue.
Yeah.
To some extent, it is a matter of personal taste. I've always been a believer in fundamental neuroscience concepts rather than applied neuroscience. So we still need to understand in detail the basic structure and function of the connections between nerve cells, and also on a larger scale the circuits in different parts of the brain, so you have to decide whether your taste is more for applied or perhaps pure neuroscience. You want to help with a disease, or do you want to understand fundamental mechanisms? I personally have always found it fascinating. Up inside your skull have a blob of jelly, basically, that can actually understand things, you see. That's a bit of a mysterious process, and it's still mysterious. Yeah. And I'm still very interested in this, and it's becoming clearer to me that there are two aspects to it. One is, how do clever animals like, for example, elephants, monkeys, dolphins, how do their brains operate, okay? And certainly the brain of a human looks very much like the brain of a monkey or even an elephant or a chimpanzee. But then the second step, or the second stage, is there seems to be something special about humans, okay? And that has always intrigued me, and it intrigues everyone, frankly. But going back all the way, most kids, teenagers, must wonder what makes humans such an unusual animal with the ability to try and actually understand the world they live in, right? And how is it possible? And what is the machinery of that? And what are the implications of that? It's still a vast area with lots of unknowns, but neuroscientists are beginning to make progress. So very recently in my own research, I've switched a little bit from the question of how does the brain, whether the rat brain or the cat brain or the frog brain or the monkey brain or the human brain, how does the brain work, to how is it that by interacting with each other, humans are able to go beyond that. And that seems to play a very important part in human intelligence, our ability to communicate, and allows us to take ideas from other humans and use them and gradually build up knowledge and understanding. And that's unique to humans, and we need to understand that process too, I think. and it's intimately related to what's going on inside the brain itself, but it's a separate problem, if you see what I mean, okay? So that's what we're working on at the moment. How is it possible for brains, even mini brains, to interact with each other and somehow go beyond the power of an individual brain, collectively, you see? So that's what actually the focus of my research at the moment is, and it's quite interesting to be pursuing it. Whether we will make any progress, I don't know, but we hope we will make a little contribution to this. And it's a problem that not many people have really thought about. It's linked to anthropology in a way. You see what I mean?
Yeah, it is. It's like philosophical and it's interesting.
It's sort of almost philosophical, and it's certainly linked to anthropology, which is a well-defined science, you know. But most neuroscientists don't think about anthropology. So I think that if you can link those two fields together, something interesting might emerge there. And that's what we're trying to work on a little bit at the moment. Making simple mathematical models and modeling on a computer, interactions between brains. Anyway, again, I didn't answer exactly the question you rose, but so let's, that's the last question, basically, right? Is our time nearly up?
Yeah. Actually, I just want to remind you, we're actually finished for the interview. So thank you for participating in the interview.